Okay, now we're going to go on to a harder concept, which is the heat calculations. Heat calculations have three separate equations. We have the change of temperature, we have a change in phase between a solid and a liquid, and we have a change in phase between a liquid and a gas. All of these equations are on your reference tables under the formulas heading on the second page, and all of the variables are also listed on your reference tables. Q is heat and it's measured in joules. Mass is M and it's measured in grams. C is specific heat, which is on the front of your reference tables. T is in temperature. The heat of fusion, when you think of fusion, think freezing. And so that goes the transition between liquid solid, but it can also go for the transition between a solid and a liquid. So it doesn't matter which direction it's going between those two states of matter. What matters is that it is liquid to solid transition. The heat of vaporization is between a liquid and a gas. It can also go reverse. So when you think of vaporization, think evaporating. You're moving from a liquid to a gas or from a gas to a liquid. The three equations are Q equals mc delta T. The delta T is actually a change in temperature. To calculate change in temperature, you say T final minus T initial. Q equals MHF. That is for either melting or freezing. Q equals MHV is evaporating or boiling or condensing. So let's do some practice questions. The first practice question, how much heat is lost when 30 grams of water is cooled from 80 degrees to 10 degrees Celsius? Well, by changing the temperature, I know that I'm using Q equals MC delta T. This is not a phase change, this is a temperature change. 30 grams is the mass. And I'm dealing with water at the liquid state. Water is a solid, anything below 0 degrees Celsius. From 0 degrees Celsius to 100 degrees Celsius, water is a liquid. Above 100 degrees Celsius, water is a gas. I'm dealing with water in the liquid phase. The specific heat of water and a liquid, which is on the front side of your reference tables, is 4.18. And then what I do, I've chosen my equation, I've identified the numbers that the problem gives me, and now I'm going to list out my variables. Q is what I am looking for. Mass is 30 grams. Delta T is equal to T final minus T initial, which is I end up at 10 degrees Celsius and I start at 80 degrees Celsius. So my delta T is negative 70 degrees Celsius. And my C for water is 4.18. I take my equation, Q equals MC delta T, and I plug in my variables. 30 grams, 4.18, negative 70. When I plug that into my calculator, I found out that I have lost 8,708 joules of energy. Now let's do an equation where we are not solving for heat, but we are solving for one of the variables. Okay, calculate the temperature change when 1.96 kilojoules of heat are added to 500 grams of copper, okay? I know that this is Q because that's my heat. It tells me that it's 1.96 kilojoules, but from your Common Core packets, you learned how to convert that just into joules, which is what you have to do. I know that I move the decimal 3 spaces to the right, or you can simply multiply by 1,000 because a kilo means 1,000. So I have 1,960 joules of heat. My mass is 500 grams. I am calculating temperature change. So that's the first key. I know that it's not a phase change, it's a temperature change. When it's a temperature change, the heat equation that I am using is Q equals mc delta T. Copper, the only thing that I need left is the specific heat. The specific heat of copper on the front of your reference tables is 0.385. Now I figured out what the problem gives me. I figured out what equation to use. I'm going to list my variables just like last time. My Q is 1,960 joules. My mass is 500 grams. My C, which is my specific heat constant, is 0.385. And the problem is asking me for my change in temperature. Write out your equation, Q equals mc delta T. Plug in the variables that it gives you. Now, I like to do one step at a time, so I am going to multiply 500 times 0.385 first. And I get 1,960 joules is equal to 192.5 times delta T. The reason I do that is because if you plug it into your calculator and you don't put a parentheses around the denominator, the calculator reads it as 3 separate problems and you'll get the wrong answer. So I like to do one calculation at a time. In order to solve for delta T, all I do is divide by 192.5. And when you divide 1960 divided by 192.5, you find that your change in temperature is 10.18 or 10.2 degrees Celsius. Now let's try a heat equation that does not have to do with a change in temperature. So we're going to use a different heat equation. I am melting 20 grams of water at 0 degrees Celsius. Melting is the transition from a solid to a liquid. The heat equation that I am going to use for this is the heat equation for the heat of fusion. Heat of fusion deals with the transition between liquid and solid. So the heat equation that I'm going to use is Q equals mHF. This is not a change in temperature, this is a phase change. You have to determine what phase change is occurring and then figure out which heat equation you need to use. The heat of fusion of water is listed on your reference tables on the front page, and that heat of fusion is 334 joules per gram. The mass in the problem is 20 grams. Write your equation, plug in your variables, and solve. So 6,680 joules are needed to change 20 grams of ice into 20 grams of water. Let's try boiling 30 grams of water. Boiling is a phase change from a liquid to a gas. I'm not changing the temperature, so I'm not using Q equals mc delta T. I'm not transitioning between a solid and a liquid, so I'm not using the heat of fusion. I'm transitioning between a liquid and a gas, which is the heat of vaporization. This is a vaporization phase change. So I'm going to use the equation Q equals mHV. The mass is given to me in the problem, which is 30 grams. HV is on your reference tables on the front side. which is 2,260 joules per gram. I wrote my equation. I'm going to plug in my variables, 30 grams, 2,260 joules per gram, and it takes 67,800 joules to boil 30 grams of water. This can also be converted to 67.8 kilojoules by dividing by 1,000.